Alright, so this is the third question of the exam. It said a ball is thrown horizontally from the top of a building and lands a distance d from the foot of the building. So, right, distance d is right here. That's the foot. No, that's the distance it reaches, right? Distance d. From the foot of the building, after having been in the air for time t and encountering no significant air resistance. If the building were twice as tall, like this case right here, the ball would have halved. So the answers are 2D, right? It would be distance of 2 times from the foot of the building. Um, we know that just by knowing these kind of examples, it's not because acceleration is constant, right? It's minus g, right? It's the gravity acting on it, and it's not like the speed is double. So the distance is not going to be twice just because of the height. So that is wrong. The first one is already wrong. Then, as we said, the velocity is not going to be twice as fast because because of the height. So these also wrong. So the answers in terms of time, as these are possible answers. So we have to test that. We have to put into an equation for constant acceleration. So initial velocity, is cut down here in the equation. So y is equal to y0, which is the initial position, plus 8 plus 18 to the second power, and then continue the equation. Y0 becomes the height of the tower of the building, which is minus, obviously it's going down and gravity is acting on it, so it's minus of uh half of gravity times t to the second power. So if we make y equals to 0, right, has obviously y is the position, y is equal to 0, that means it's landed, and the question says horizontal lands a distance. It says that it lands, the ball lands, so the ball goes up to y equals to 0. So that's the time that really matters. So we make y equals to 0, and then the height becomes equal to the opposite of this. So we see the negative sign, it becomes positive sign right here. And so here we have, the 2 in the equation goes here, gets canceled right here, and gets added here. So 2ho divided by g, right? G goes and divides. And then we have equals t to the second power. And then we have initial t equals the square root of 2h over g. So that's what we have for now. And then to do the equation for the second building, it's basically the same thing except that the height's going to be doubled. So we have a 2h here. So following the same equation, we make y equals to 0. So we have 2h equals to half of gt to the second power. Obviously this goes here, so it becomes 4, right? So 2 times 2 becomes 4. And then obviously g also divides, right? G also comes here and divides. And then we are able to separate. This is a smart move. This is not everyone who's able to see it, but we can separate the 2 and isolate the 2ho over g, which we saw is equal to this, right? This is the same thing as this. So we're able to draw that this number, right? This variable right here is equal to this, right? So that's 2 times this variable. And then in order to take off the power of 2, we have to obviously, it would be like this. So t equals to t, but obviously this cancels out, right? Times the square root of 2. So final answer becomes this, becomes t square root of 2. So the only answer that's the same as this one is letter C. This one's wrong too. So that's the final answer.